Okay, so now what we're going to do is we're going to subtract mixed numbers with what we call regrouping. And before I begin, let's look at this problem that I have here. I have 8 1/4 minus 5 3/4. So looking at the problem, obviously 8 1/4 is bigger than 5 3/4. Okay, so I have 8 and some change minus 5 and some change. But when it comes to following the normal steps of adding and subtracting mixed numbers, the problem comes with the fraction part of the problem. Right, so normally I do 8, the whole minus the whole, and then the fraction minus the fraction. So it'd be 8 minus 5 is 3, and then 1/4 minus 3/4. But there's a problem there. Okay, I can't take away 3/4 from 1/4. That put me in the negative numbers, and we're not there yet. Right, so I can't do it by following the normal steps. So what I'm gonna have to do is I'm gonna have to change my problem with what we call regrouping. Okay, but before I begin, and ignore this for now. I'm gonna just kind of block this off real quick. So don't ignore that. Ignore that for now, and I'll erase it later. So a common problem that students often do is that they flip the numbers around with the fractions. So they'll take 8 1/4, and they'll put the 5 3/4 fraction part to that 8 and do 8 3/4, then minus 5, and then they'll take the fraction from the 8 holes and put it to the 5 hole, right? And this is actually incorrect, all right? I'm going to leave this up here for now, and I'm going to do it method 1, and I'm going to show you why that is not true, okay? It's just a common mistake that a lot of students do, but that will not get you the correct answer. All right, so method 1, borrowing from the whole. So if you notice so like I just said, the problem that I have with this problem is that I can't take away 3/4 from 1/4. So what I need to do is I need to make this 1/4. I need to make it a bigger fraction, but I need to maintain the same value of this entire expression. And so I'm going to do so by borrowing from that whole. So borrowing from that 8. So what's going to happen here is 8 1/4. I'm going to borrow from that 8, and I'm going to make. So I'm going to borrow from that. I'm going to borrow one whole, so that A becomes a 1. All right, and then I'm going to make that other whole as a fraction, so 4/4. Okay, that's the same thing as one whole, right? They're equivalent. And then my fraction, my 1/4, stays the same. Okay, and so now what I did is I borrowed from that whole, and I can combine those two fractions, and that's going to make that 1/4 bigger. So what's going to happen is that becomes 7 and 5/4. Okay, now I can go ahead and plug that back into the expression and solve it. So I have 7 and 5/4. Put a little arrow down here, minus 5 and 3/4. Okay, so now we can follow our normal steps. So 7 minus 5 equals 2. Circle that. And then 5/4 minus 3/4 equals 2/4, which equals 1/2. All right, so both these are okay. You can use either one. And now I'm just going to combine but I'm only going to use one. So either one. I'm going to combine my whole number, which is 2, and I'm going to combine by half. All right, so that is my answer. All right, 2 and 1/4 is okay too, or 2 and 2/4. All right, but like I said, you normally say, can I have half your candy bar, or can I have 2/4 of your candy bar, or can I have half of your candy bar? All right, so usually try to condense your fractions, simplify them as best you can. All right, so now let's go over here, and I'm going to show you why this does not work. So if you round these two together, so 8, if I round these to the nearest whole number, that's going to be rounding. I'm going to have 8 minus 6, okay, because 3/4, I'm going to round that 1/4 down to 8, and that 3/4 up to 6. So 8 minus 6 equals 2. My answer should be pretty close to 2, okay, and that 2 and 1/2 is close. I'm just estimating here, rounding. I said rounding, but estimating. So my answer should be somewhere around 2. Now let's look what happens here if I follow this. if I do this method, or do this, do it like this. So what I did, I flipped the fractions around to the whole number. So I have 8 minus 5 equals 3. 3/4 minus 1/4 equals 2/4, which equals 1/2. And then so I combine my numbers, so I have 3.5, which was closer to my estimation. 2.5 or 3.5. And 2.5 is much closer to my estimation. All right, so make sure you do not do this. It would not work. 100% of the time, it will not work. I'm showing this to you guys because that is the number one mistake that all students do, or not all students, but a lot of students make when it comes to subtracting mixed numbers. All right, so I'm going to erase this and I'm going to show you method 2. And I actually prefer method 2, but it's up to you. So method 2, I'm basically going to convert both those numbers into an improper fraction, and then I'm going to subtract them. So I have 8 1/4 minus 5 3/4. Okay, so 8 1/4 as an improper fraction would be 33/4, and I'm going to put a semicolon here. 5 3/4 as a mixed number or improper fraction would be 23/4. Okay, so now I can plug in those improper fractions in place of the mixed number. So my problem becomes 33/4 minus 23/4, and that's going to get me 10/4. Okay, all right, now 10/4 is an improper fraction, so 10/4 equals 2, and 2/4, which even better, equals 2 and 1/2. All right, and so there is my answer. So both these are okay as an answer. I prefer the simplified, but as long as you get rid of that improper fraction, then I'm cool. Okay. All right. So that is how the two methods on how you solve improper, you subtract mixed numbers. All right. So for the extra example, you guys can, if you're ready to move on, go ahead and move on. Make sure you do the independent or the on your own, and that's going to be followed by the independent practice that I'm going to be checking for results. And actually, I may not have an independent practice today. I probably won't, actually. So extra example, if you want to stick around for the extra example, go ahead, pause the video, and resume when you're ready to go. And I think I probably will have a couple questions on independent practice now I think about it. But all right. Anyway, if you want to stick around for the extra example, hit pause and then hit resume when you're ready to go over it. All right. So 5 and 5 twelfths minus 4 and 7 twelfths. Okay. So first I'm going to write my problem. So 5 and 5 twelfths minus 4 and 7 twelfths. All right, I'm going to borrow. So the first thing I'm going to do is borrow. So 5 and 5 twelfths becomes 4 plus 12 twelfths plus 5 twelfths equals 4 and 17 twelfths. All right, now I'll go ahead and plug that into, replace that with the 5 and 5 twelfths, and then subtract. So 4 and 17 twelfths minus 4 and 7 twelfths. All right, so 4. So 4 minus 4 is 0. 17 twelfths minus 7 twelfths. Let me erase that. Equals 10 twelfths, which equals, I can reduce that to simplest form. That's okay. If that's your answer, but I'm going to go to reduce that to simplest forms. I'm going to divide both by 2, and I get 5 6. So that is my answer. All right. Number 2. I'm going to convert both into an improper fraction. So 5 and 5/12 equals 65/12. All right. Semicolon 4 7/12 equals 48, 50, 55/12. All right, so now I'm going to rewrite my problem. So 65/12 minus 55/12 gives me 10/12. All right, and then 10/12 equals 5/6. And that's my answer. All right, so go ahead, do the extra practice, and resume on to the independent, the quiz.